All right, this image might be a little bit small for you to actually read on your computer screen, but I'm looking at basically numbers 18, 19, and 20. And it starts off, well, we have to say what set these numbers belong to. So you need to recognize these different categories and understand what numbers are in them. Natural numbers, those are the first ones that humans invented. So that would be 1, 2, 3, and that keeps going. Whole numbers, they finally decided to include the number 0, and then 1, 2, and that continues. Integers, this includes our negative numbers, so well, I should put ... comma, -2, comma, -1, comma, 0, 1, 2. All right, so the integers, those are, this is an example of integers. When you get to rational, irrational, and real, it's harder to show them because there's, how to explain, there's a lot of them. But just rational numbers, they can be written as fractions. So 3/4 would be irrational. Even the number 5, because the number 5 can be written as 5/1. Okay? Irrational numbers are decimals that do not repeat and do not terminate. Real numbers are all of the numbers that you're going to see in this class. They do not include imaginary numbers, which we don't get to until 1033. All right, so a -1/4, you would look at this and say it's not natural, it's not whole, it's not an integer, so you can't include it in anything until you get to the rational numbers. So it's a rational number, and all of the numbers that we deal with are real. So -1/4 would be rational as well as real. In fact, I'm just going to use the R with 2 bars. That's a symbol for real. 0 is a whole number. It's not a natural number. So it's whole, integer, rational, and real. Got a lot of writing to do. Whole, integer, rational, and my fancy symbol for real. Okay, and then 17 is also a natural number, whole number, integer, rational, and real. I'm not going to bother to write that one. All right, so let's take a look at moving along. We'll look at number 23. And let's see, we are to, I think I'll zoom in a little bit here. Okay, number 23. They want us to use the commutative property. Remember, commutative means, well, to commute means to move. So the commutative property, things move. So on this side of the equal sign, we have 3x plus 26. On the other side of the equal sign, we'll have the 26 show up first, and then plus 3x. So we use the commutative property right here. Okay, let's see any others that we're going to do. Number 26, name the property illustrated. So when you're asked to name the property, you look on each side of the equal sign and you say, well, what's different? Here we have the 5 and the 12 grouped together. Over here you have the 1 and the 5 grouped together. So they're making different numbers associate. Okay, and the operation is addition. So this is the associative property of addition. Okay, that's that one. And number 28, we'll take a look at that right here. What they're asking us to do is identify the property. Okay, the multiplicative inverse of a number is the number that you use to multiply and get 1. All right. So it's a little bit hard to see here, but 1/2 times 2 is a 1. So let's do another example. So anyway, on this one, that would be your answer. But if I had, let's say, 3/4, the multiplicative inverse of 3/4 would be 4/3, because when I multiply them, I get a 1. Okay? So this illustrates the multiplicative inverse property. And let's see, the next one we're going to be concerned with. We're going to solve an algebraic. Actually, we'll just stop there. For number 29, they tell us to use the distributive property to rewrite the algebraic expression in the simplest form possible. They could have just said simplify the expression, but they're actually being a little more explicit, saying you'll use the distributive property. All right, if you have basically a term outside parentheses, it means to multiply whatever is inside parentheses. So this -4/9 has to come in and hit each term there. So that will be a -4/9 times 9x. I'm going to put that 9x over 1, just so I'm looking at fractions here. Sorry, they're a little bit uneven. All right. Then here's the plus sign. Then this -4/9 times your 27. -4/9 times our, we'll make that 27 over 1. Again, if I have a fraction, I'd like to have all fractions. And then finally, this plus 6x just comes down. All right, I think you'll see these clean up. I believe they chose it carefully. 9 goes into 9 once, 9 goes into 9 once. So you have -4x. Okay. Well, actually, I was going to bring down the plus sign, but I'll bring down the plus sign. Now we have 9 goes into 9 once, 9 goes into 27 3 times. -4 times 3 is -12. Okay, and we just bring down our plus 6x. Okay, and now these are like terms. -4x and a positive 6x. We can combine those, and that gives us 2x. And for this, 2 terms in front of a number, I like to clean that up. I use the rules for multiplication. Positive times a negative is a negative, and bring down your 12. So this would be your simplified answer. Okay.